PVC piping there. It's a fire hazard, and if that catches on fire in a return air plenum, you're breathing toxic smoke. So that's a problem. Any low voltage wiring or cabling that you put up there would have to be plenum rated so that it does not produce a toxic smoke if it catches on fire. So that's just another thing to keep in mind. A lot of this the engineer takes care of, and it's automatic, but if you don't have a good engineer, he may forget it, and then we're all in this together. If your plans are connected to his plans, all of a sudden they're asking you, the architect, why'd you let that happen? Well, I should have got a good engineer to start with that knows about all this stuff. So it's we catch stuff that y'all miss, y'all catch stuff that we miss, so it's all together. You know that obviously electrical is connected to both plumbing and HVAC because plumbing fixture or electric water heaters have to have power. All the units that are HVAC have to have power. But how is HVAC connected to plumbing? Anybody? They're connected. HVAC and plumbing is connected. How are they connected?
I would imagine like the HVAC systems have some kind of water that's flowing through them.
Condensate drain. The indoor unit has a cooling coil that produces condensate water. Well, that water can't just drip into the floor. It can if you have a hub drain. But that's what you want to do is provide some sort of drain for that unit, be it a rooftop unit or an air handler indoors, so that as it produces water, and down here the humidity is high. So I've seen big units that looks like you've got a water faucet. It's just, most of them just drip, but I've seen big units that just pour water down a hub drain. So if you're way inside the building somewhere and you have not got a restroom or anything close by, then you get to be very creative. In some cases, we have to pump the water up and send it outside, which we don't want to do. We'd rather let gravity take care of it. So that's one place, one that I know of where HVAC and plumbing is connected. That was mechanical. Now back into electrical a little bit more. Electrical, you've got pretty much it allows you to have light both indoor and out. You've got switch gear that you've got to make sure you accommodate. A big building like this will have massive switch gear. It'll probably have 4,000 amp at 480 volt gear that's 4 feet wide and 3 feet deep per section, and there may be 5 sections back to back. I mean, and there's big switches like my arm that rotate through and control 4,000 amps. There may be several of them. Well, you can't just stick that in that little closet over there. It's got to have, sometimes it's got to have an entire room. So the bigger the building, the bigger the service entrance, the bigger the gear. You don't want to just, after the fact, think about, well, where are we going to put our electric room? And another consideration is on your site plan, where's the power coming in from the building? You try and get over on that end of the building and minimize your copper runs and your cost of your feeders. Copper, some of these copper lines are like $10 a linear foot. And then you have, you don't have your one run, you've got 4 runs. You've got phase A, phase B, phase C, neutral. And then sometimes you have to parallel those. So when you get to 3,000 or 4,000 amps, you have to take really big wire and put 1 run and then multiply that times 8. So that's 8 runs, and if it's $10 a linear foot, but you got to go 40 feet, y'all do the math, it gets extremely expensive. So it's better, and there's a trade-off here, because the closer you are, I don't know if I should get to that yet, the closer you are, the higher your interrupt rating is. A big thing on electrical is the transformer has got an available fault current, and that's the number one thing I have to check for is available fault current. Well, the closer you are to that transformer with your gear, the higher your fault current is. The longer away you are, the lower it is, but you're running extra wire, so it's a trade-off there, and that can be fun to figure out. But everything in here that's electrical is connected through a system of wires and conduits. These lights are probably going through a conduit, a pipe about that big around, with wire about smaller than this. So, and they will have they'll have 2 wires, a hot and a neutral. Well, they have 3 of ground, but we'll talk about that later. They have 2 wires, only 2 little wires to the lighting. And the same thing for the receptacle. So these are little, they get little feeders. the air conditioner gets big feeders, depending on the current. And then back in electrical, anything that anybody else doesn't pick up, electrical picks up. If it's fire alarm, electrical's got it. If it's PA system, public address, if it's any other system that doesn't belong to plumbing or mechanical, electrical has it. We draw it, we detail it out. Typically, we would just show a system of infrastructure, rough it in, show blank cover J boxes with conduits above the ceiling with a pull cord, and so you go in there and you stick your devices on that. So that's pretty simple. It doesn't require much space. It's just something to think about. And again, if you have a plenum, a return air plenum, any wiring that you would put up there would need to be rated for that plenum rated cable. Okay, so we talked about AIC. The AIC rating of every switchgear that you specify, or that I specify, has got an AIC rating. And we're talking 22,000 ounce, 35,000 ounce, 65,000 ounce, 100,000 ounce. That rating tells me that if you can have a fault, and when I say fault, think short. There's a short somewhere. Two wires came together that should not come together, and massive amounts of current flow. Well, if that panel board is not rated for that current, it'll blow off the wall, literally blow off the wall and kill somebody, or catch the place on fire, or all the above. So that's why it's very important to establish, when I get a project, I ask the AEP, what is your available fault current? If they can't tell me, I say, what is your impedance of your transformer? I'll figure it out, which I can do. And then I'll know what it is. So if the available fault current is 15,000 ounce, then my 22,000 ounce AIC rating is good. I'm above that.
What does AIC stand for?
Asymmetrical interrupting current. And there's a SCCR on the gear sometimes, and that's a short circuit current rating. SCCR, AIC, they're not the same thing, but they're related. So that's
Abbreviations again? ACR and what?
AIC is asymmetrical interrupting current. Asymmetrical, as opposed to symmetrical. It's AC, so it's very asymmetrical. And the SCCR is short circuit current rating. Okay, what did I skip? Did I skip? I did not skip, did I? There we go. I was almost skipped that. Okay, plumbing. Expanding a little bit on plumbing is plumbing is very particular about ADA, accessibility, or Americans with Disabilities Act, or
yeah.
something like that.
Handicap.
Any public space needs to be accessible these days, and that's a good thing. If we have somebody's coming in a wheelchair that have no legs or something, I want them to be able to do everything I can do within reason. Access the toilets, access the lavatories. Can't get upstairs, so we have elevators. And outside we have ramps to where they don't have to pop off the curb. When you're laying out a restroom, as an architect, there's very specific requirements of laying out that restroom, both in mounting heights of water closets and side-to-side clearance. And then the same with lavatories, you have to have knee space to roll up under the lavatory. All of that is part of, we as engineers have to make sure that we're specifying ADA fixtures and that it's also laid out correctly. We don't lay it out, you guys lay it out, but we look at it and say, that's not gonna work. We see that all the time. If we're renovating a building, the old restrooms, they don't match, they don't work, they're not big enough. So we tear those out and draw a new one in, and then it works. Mounting heights we talked about mounting heights of devices. A part of that is ADA, that switch is no more than 48 inches high, no lower than 42, somewhere in there. When you're laying out restrooms, if you have a brand new building, so you've got a brand new 5-story building and you want to lay out the restrooms, a good way to do that is to mirror those restrooms and have a chase in between the restrooms so that you've got access panels behind the appliances, behind the fixtures to access piping, valves, elbows, This is a very efficient way to do it. Instead of have a restroom here and one over there and one over there and one over there, just line them all up and put them back to back with a chase in between. Then, if it's say a 5-story building, you also want to stack those so that you have a chase, an X by Y space to run hot and cold water in, drains and vents down, or drains down and vents back up. Okay? It's a lot more efficient that way. And another thing is to establish early on the site plan, what's the lay of the land? Is it flat, or does it tend to go off this way or go off that way? Because the flow, as you draw it, you will want to tend to flow the sanitary sewer out that direction. If that's the low end over there, you want to send it that direction. Corpus is pretty flat, but I haven't seen a site yet that we didn't have some sort of flow. It's, maybe, and you only require about an 1/8 inch per foot to actually get water to flow. And once you get the water flowing, you're good. So those are considerations when you're laying out a building for plumbing. Try and mirror them as much as possible. Try and stack them as much as possible. If you mirror and stack restrooms, you're going to minimize the length of the runs of the sanitary sewer, the drains and vents, and the hot and cold water piping. And gas piping if you have to get a gas to a hot water heater. Same thing. When you drain drain a tub, it won't drain without a vent. It'll sit there and it'll bubble and it'll burble, and it may eventually drain, but the vent is what lets it breathe. So those vents have to go up through a wall or a chase out the roof, and they vent outside, okay? So, and they're sized according to how many appliances do I have on this drain. It could be a 2-inch vent through roof, it could be a 3-inch vent through roof, or 4-inch. So another consideration is, and if you have the chase there already, and you're already running hot and cold water, drains, then you can vent back through that same vertical chase. If not, it's going to have to go through a wall somewhere. Well, if this wall and the floor above it, if they're offset, then guess what? You get to do some of this, and we don't want to do that if we can help it. It'll still work, but it's better to try and get the vent out as straight as possible. And it's basically just to let the drain breathe, so it will drain properly. In a commercial kitchen, that's a different animal. You've got both sanitary sewer and you've got what we call grease water. Anything that produces grease, a 3-compartment sink, a hand sink, a hub drain, a floor sink, those kinds of things you would send to grease. And then when it leaves grease, it goes out into the main sanitary sewer. There's one thing you never want to send to grease in a kitchen. Can you think about what that is? And it's for a really good reason. You never want to let your ice maker or your freezer drain into the grease. Why would you not want to do that? Anybody think of that?
It freezes the grease for one thing.
Exactly right. It freezes the grease and it stops it up and you're done. Because that cold water gets in there and it makes it hard. Where hot grease normally, it'll flow on out if it's got detergent or something. But you start sending cold water down there, and at some point it's going to get cold and it's going to start to build up, and that's exactly right. That's exactly right. So that's just one little thing. If you have an engineer doing that to you, say, stop, don't do that. Okay. Okay. How am I doing on time?
Got 35 minutes left until the bell rings.
Y'all aren't asking enough questions. I'm just getting started. Y'all want to talk about college football? No, I'm just kidding. I'm from Alabama. Roll Tide. I guess I'm in it now. Okay, let's get to the meat of the subject. Lighting, indoor and outdoor lighting. Lighting is one of the big budget items on an MEP set of plans. You guys can be extremely helpful as architects with lighting layouts. You can, who knows what a photometric program is that shows foot candles? You guys know anything about that?
They just started lighting, so.
Okay. There are programs that you can feed parameters in, feed IES files into for a certain fixture at a certain mounting height with certain reflectance on the walls, the ceiling, and the floor, that for a given number of fixtures of a given type, you can get 35-foot candles right here, 3 feet off the floor. Or you can make them more dense and brighten them up a little bit, get 50-foot candles here. The program can either tell you the foot candles for your given lights, or you can say, I wanna have 50 foot candles, tell me